Hi guys, Miss Powell here. Today we're going to talk about rewriting absolute value functions and graphs as piecewise functions. So to get your equations for each piece of our piecewise function, we have 3 steps for you. Number 1, we want to identify the vertex of the absolute value function and then rough sketch what the graph would look like. Step number 2, rewrite the function into 2 pieces. The first piece keeps the signs of what is inside the absolute value bars the same, and the second piece negates the signs of what is inside the absolute value bars. Step number 3, we want to clean up each piece and write as a piecewise function with the constraints. So the constraints come from the x value of the vertex of the original absolute value function. You can also refer to the constraints as the domain for each piece of our piecewise function. Either way. All right, so for examples number 1 through 4, the directions ask us to write the following absolute value functions as a piecewise function algebraically. So sticking with our process from above, the first thing that I want to do is identify the vertex. The vertex here on this function is 0, -3. So if I go ahead and make a rough sketch of what this would look like, it actually would look like this. I know that this is an absolute value function that's positive, meaning it opens up, because remember my a value here, which is the number that's directly to the left of the absolute value bars, is in fact positive. So this absolute value function opens up. It has the vertex of 0, -3. All right, now we're going to move on and look at step number 2. For step number 2, we want to go ahead and set up 2 cases. So the first case is where what is inside my absolute value bars remains the same with respect to the signs. And in the second case, what is inside my absolute value bars gets negated, right? So every term that is inside my absolute value bars gets a sign change on it. So with the first case, what is inside stays the same, so x -3. In the second case, what is inside my absolute value bars is negated. So -x, bring down your -3. It does not change. So now in step number 3, I want to actually go ahead and start building my piecewise function. So step number 3, I have f of x is equal to. So now here is where I go back and I look at my rough sketch of the function. So with my rough sketch of the function, I want to consider the left-hand side of this graph first. So we can see that the left-hand side is a linear function with a negative slope. So because that's the case, I know that it corresponds to this second piece. So I'm going to put that first in my piecewise function. So -x -3. Then the question is, what are my constraints? Well, this is for all x values that are less than 0. Okay, so there we are with that piece. And now, second, I want to go ahead and look at the right-hand side of this absolute value function. Well, obviously, that is a graph of a line with a positive slope. So that corresponds to this guy. So he's going to go right below, so x -3, such that our x values here are actually greater than or equal to 0. All right, so curly Q brackets, we are done. Looking at example number 2, I want to follow the same logic as above, and the first thing that I want to do is identify what is my vertex. Vertex here is the point -2, -3. This graph also opens up because its a value is positive. So here's what the graph looks like as a rough sketch. This is our vertex point, -2, -3. Step number 2, I want to set up our 2 cases. So in the first case, what is inside our absolute value bars remains exactly like it is. So in this case, x +2, bring down your -3. In our second case, we want to go ahead and negate the signs of what is inside the absolute value bars. So we now have -x -2, bring down your -3. It still remains the same. Cleaning up each one of these, we get x -1 and we get -x -5. So now we have 2 pieces. We need to go ahead and start building our piecewise function. So this is step number 3. I don't want to get all jumbled up here, so I'm going to use a different color. So I get f of x is equal to. Well, now I want to consider the left-hand side of my graph. Obviously, that's a linear component, right, with a negative slope. So it corresponds to this piece of my function. So -x -5, and this is for all x values that are less than -2. Remember, I get that -2 from the x value in my vertex. Okay, that's where that number comes from. It's not magic. I didn't just pull it out of thin air. It is with respect to the x value of the vertex. Now I want to consider the right-hand side of this absolute value function. That is a line with a positive slope, so it has to be that component. So here I have x minus 1 for all x values that are greater than or equal to negative 2. If you are asking yourself the question now, Miss Powell, how do you know that x minus 1 is for x values greater than or equal to negative 2? And that negative x minus 5 is for x values that are less than negative 2. How do you know that it's not less than or equal to negative 2 for that top function? And the quick answer is I really don't. I know that I have to include an or equal to portion in one of these pieces or components. I just tend to stick it on the bottom. Okay, so if you were to say that your piecewise function was negative x minus 5 such that x is less than or equal to negative 2 and x minus 1 such that x is greater than negative 2, you would still be correct. All right, I generally tend to put it on the second equation. All right, looking at example number 3, following the exact same logic. The first thing that I want to do is identify my vertex. So my vertex here is the 0.56. The second thing that I want to do is I want to set up my two cases, right? So my first case assumes that what is inside my absolute value bars keeps the same signs. So bring down the negative, open a parenthesis, x minus 5, close your parenthesis, bring down your plus 6. So everything has remained the same. The absolute value bars are gone, replaced with parentheses. In the second case, I'm going to bring down the negative, but this time I'm going to negate the sign of everything that is inside my absolute value bars. So negative x plus 5, bring down plus 6. Okay, now I can clean up each one of these. Distribute the negative, and you get negative x plus 5 plus 6. So negative x plus 11. Distribute the negative, positive x minus 5 plus 6. I end up with x plus 1. Okay, so as you can see, I forgot to make my rough sketch here right after I identified the vertex. So I'm going to go back and I'm going to do that now. Well, the rough sketch of this graph actually looks like this. How do I know it looks like that? Because be mindful, this guy has a negative a value. So if we have a negative a value, that signifies the absolute value function is in fact opening down. Our vertex here is at 5, 6. So now that I have that identified, I can go ahead and start building my piecewise function. So I want to look at, I'm going to change colors, f of x is equal to, I want to look at my left-hand side here. And what I can see is that looks like a linear function with a positive slope. Therefore, this is the piece that corresponds to. So I'm going to put it on the top. So x plus 1 such that my x values need to be less than 5 here in this case. How do I know less than 5? Well, because this is the piece of the graph that I am looking at, is this component right here. And if I put that on an x and y axis, this little piece right here is going to continue to extend negatively indefinitely towards the negative x values. So now I want to consider what's happening here on the right-hand side. On the right-hand side, that's a linear function with a negative slope corresponding to this piece. So negative x plus 1, plus 11, such that my x values need to be greater than or equal to 5. Okay, curly bracket it up, and you're done.